Okay, welcome back for part 2 of our lesson 36, more on distribution, and then minus signs and negative exponents. We worked example 1 and 2 in the last video. Now we're going to move on and discuss negative exponents. Before we can really jump into these examples, and once again, feel free to pause the video, start writing these examples out if you want so that you can actually listen to and watch the instruction before or instead of writing the examples while I'm talking and then therefore not really hearing what's being said, because the explanations are important in this problem or in this lesson. All right. So before we can jump into the examples 3 through 7 here, we need to discuss the rules for dealing with negative exponents. So you might remember, actually I'll keep this in red. You might remember that we did redefine this expression a to the negative m. I'm writing these in red because these need to be memorized. These are rules that have to be known. They have to be second nature. We can't be looking them up in a book every time we have to use them. All right? So a to the negative m is rewritten as 1 over a to the positive m. So in other words, if the exponent is negative, it means take the entire expression and move it from wherever it is. In this case, it's in a numerator. A to the negative m is technically written in this case over 1. We just don't show it that way. But you move it, it shifts. The negative exponent shifts the entire expression into a denominator. And when it shifts, the exponent changes to a positive. All right? But it works the other way also. In this second definition here, the a to the negative m is in the denominator to begin with. And so the negative is going to take that whole thing and it's going to move it up. So now we get a to the positive m when it shifts up. Again, the negative exponent forces it to shift from its position either to the top, or if it's on the top already, it shifts it to the bottom. In other words, a negative exponent means reciprocal. Negative exponent means reciprocal. We take the reciprocal of whatever it was that we were given. All right, and so the last example we actually hadn't talked about until now, but notice that we have two bases, a and b, and they're different, so they can't be reduced, but both of them have a negative exponent, which means they're both changing positions. The b to the negative n is going to move up, and the a to the negative m is going to move down. So if we do that, we end up with b to the positive n. Remember, when they shift, they change signs. B to the positive n over a to the positive m. When they move positions, the sign becomes a positive. All right? Okay, so with these three rules, let's jump into some of the examples. So this first example, notice very clearly that the negative in front is not in parentheses with the 4. Unlike example 4 here, where the negative is in parentheses, and so the negative is having the exponent applied to it. In this problem in number 3, that negative in front does not get the exponent negative 2. Only the 4 has the exponent of a negative 2. So only the 4 is shifting down. The negative stays on top. Well, when you shift it, you're going to leave a 1 in its place, a factor of 1. And so the 4 shifts down, and it gets a positive exponent when it shifts. And then we can evaluate that positive exponent. So the answer is negative 1 over 16. Now notice the difference between that and the next problem. Again, the answer here is negative 1 over 16. In the next problem, the negative is moving with the 4 because it's in parentheses, and it's all raised to the negative exponent. So this is 1 over negative 4 squared. Notice that negative did not change signs. Only the exponent changes its sign when the expression shifts. Only the exponent. So this negative 2 turned into a positive 2. But the negative on front, that's not reciprocal. That's literally the negative of 4, the opposite of 4. All right, so what we're doing here is 1 over negative 4 squared. Well, it's a negative raised to an even power. So when you square a negative, you get a positive. So the answer is positive 1 over 16 instead of negative 1 over 16. All right, let's go again. In this case, we're cubing it. We have a negative in front, we have a negative inside, and it's raised to a negative 3 power. Well, the negative 4 is raised to a negative exponent, so it gets the shift. This negative hanging out in front is not raised to the exponent. It stays put. So we have negative 1 over negative 4 to the positive 3. Once again, when it shifts positions, the exponent turns into a positive. So negative 4 cubed, well, that negative 1 is still sitting up top, but a negative raised to the third power stays a negative, and 4 cubed is 64, so it's negative 64. And now the negative over a negative becomes a positive 1 over 64, because a negative divided by a negative is a positive. Now, one other note on this. I know what some of you may be thinking when you look at this problem. I'm going to go back to the original over here. You might be going, oh, well, a negative in front of a negative, that's going to be a positive. That negative turns that negative to a positive. A double negative is a positive. No, that does not work here. You can't just cross those off. You would end up with the right answer in the end, but it's only blind luck that makes that happen. You cannot do that because exponents come first in order of operations. Remember, PEMDAS. Please excuse my dear Aunt Sally, right? Exponents have to come before multiplication. Multiplication is the same as a minus times a minus here. If you cross those minuses out because it's a double negative, you're doing a multiplication, and you failed to recognize that there was an exponent going on first. You have to evaluate this exponent before you can do that. And once you do, you end up with a negative 1 over negative 64, and then that's division, and a negative divided by a negative is a positive. All right, let's move on to the next one. In example 6, we have just the 4 this time. I don't know why I switched to blue. Let me go back. Just the 4 is raised to the negative exponent. So only the 4 shifts. Notice the negative on the bottom is going to stay there. So 1 over, not 1, but 4 squared over negative 1. And of course, recognize once again, the negative on the exponent disappeared because we shifted it. So the negative goes away. In other words, once you shift it, it's like you're applying that negative exponent. The negative exponent means reciprocal. Once you take the reciprocal, the negative goes away. All right, but this negative on the bottom stays there. And so this is 16 over negative 1. 16 divided by negative 1 is negative 16. All right, rolling right along. Another similar problem. Again, all these problems dealt with 4 and negatives and exponents on those negatives. In this case, we have the negative 4, all in parentheses, raised to a negative 3. So it's going to shift up. We're going to take the reciprocal of just the negative 4. And so therefore, that's negative 4 to the positive 3. But we left this negative on the bottom. So there's still a negative 1 on the bottom. Negative 4 cubed is negative 64. It's all divided by negative 1. And negative 64 divided by negative 1 is positive 64. All right, hopefully that makes sense. I've got a whole bunch more practice problems down here. I'm going to save that for one final video. I strongly recommend you watch the video on these extra practice problems so that you can see how we do it, how we work these things in a more complicated setting when we've got variables involved. Notice there's a bunch of variables in these. There were no variables in examples 3 through 7. All right.